Good morning, everyone. Today in our discussion, we look at mole calculations. And to focus our discussion, we're going to look at the November 2019 final grade 11 chemistry paper. And we're only going to look at the mole calculations and definitely not at the definitions, just the calculations. So in 6.1 there, they tell us that potassium permanganate, KMnO4, burns with a bright flame when a few drops of glycerin are added to it. The incomplete equation for the reaction is given over there. And the first question, 6.1.2, that we're going to do, they tell us that the composition of glycerin is as follows. They tell us there's 39.13% carbon, 8.7% hydrogen, and 52.17% oxygen. Now remember, percentage is out of 100. The percentage that they give you here is a mass percentage. So it's that percent of the total mass. So to do this, we're going to say, let's take 100 grams. If I've got 100 grams of this glycerin, that will mean I've got 39.13 grams of carbon, 8.7 grams of hydrogen, and 52.17 grams of oxygen. And to get the empirical formula, I need to get them in the ratio C to H2O, but that is not a mass ratio. That is a particle or a mole ratio. So I first need to convert the grams to moles so that I can use this. So I'm taking my mass and dividing by the molar mass for carbon, hydrogen, and oxygen to get the number of moles. And then I can put them in the ratio C to H2O. So we ended up with that 3.26, 8.7, and 3.26. But I need whole numbers for my equation. So here I'm definitely going to divide by the smallest one. And then I ended up with 1, 2.67, and 1. Now here, 2.67, that 0.67 is too much to throw away to round down or to round up. I will have to add a third. So that 2/3 is going to tell me that it will be better to multiply the whole thing by 3 in order to get whole numbers. So I'm going to multiply by 3 and then I end with 3, 8, and 3. And that will give me my empirical formula, C3H8O3. In 6.1.4, they ask us to calculate the mass of manganese oxide that can be prepared if 18 grams of potassium permanganate reacts with an excess of glycerin. So here what is important is they give us 18 grams of potassium permanganate and they ask us the mass of the manganese oxide. So I've got a mass and I'm looking for the mass. So what I'm going to do is I'm going to start off with the mass that they give us, which is for potassium permanganate, and I'm going to work out the number of moles. And then I'm going to convert from the number of moles of potassium permanganate to the number of moles of manganese oxide. And then going to convert that to mass. So let's start with the first one. You have to work out for potassium permanganate. You have to work out that molar mass. And then you end up with the number of moles over there. Converting from one to the other, that's always going to be a ratio. And if you look at the equation, they're in the ratio 14 to 7. So 14 moles of potassium permanganate will make 7 moles of manganese oxide. But we don't have 14, we have 0.131, and it's in the ratio 14 to 7, or you can say 2 to 1. And then we end up with the manganese oxide of 0.0656. Now remember here we work with more places after the comma, and only in the final answer will I round to 2, which is not even necessary because they ask us for a minimum of 2. You may leave more. So now I've got the moles of manganese oxide and I'm going to work out the mass. So if the moles is for magnesium oxide, then the mass has got to be for magnesium oxide as well. And then you end up with 10.38 grams. Moving on to question 6.2. During a reaction, 1.5 grams of impure sample of sodium chloride reacts with 100 cube centimeters of sulfuric acid of a concentration 0.1 moles per cubic decimeter at room temperature. Now, first off, that 1.5, the most important thing is that is impure sodium chloride. So don't work with that 1.5, right? That 1.5 is impure. The true sodium chloride in there is going to be less than 1.5. So don't use the 1.5 in a mole calculation. Then they tell us that the sulfuric acid, they give us a volume over there and they give us a concentration over there. And in 6.2.2, they ask us to calculate the number of moles. So we're looking for N. So this was easy. They gave us both the concentration and the volume, and we just used that in our solution equation to get the number of moles. Now, in the second part of this question, they tell us that during this reaction, they tell us on completion. So for the whole reaction to take place, 460 cube centimeters of hydrogen chloride gas has formed. So now they ask us for the percentage purity. Percentage purity is not a difficult question. It's to understand what you have to do that might be difficult. So let's start by thinking about that percentage purity. Percentage purity will be the mass that is really sodium chloride divided by the possible mass, which is the whole sample. The whole sample could have been sodium chloride. So here we need a mole calculation to work out that mass of sodium chloride. So I'm going to start with what they give us, that 460 cube centimeters, and work out the mass of the sodium chloride that reacted. So this is not a difficult question once you've decided what you have to do. So first, converting that volume to moles. Now, just something else, they tell us we have to use 24.45 cube decimeters as our molar gas volume because they're not at standard temperature and pressure, which is 0 degrees Celsius. They're at room temperature. So here I'll use the 24.45. So divide by 24.45 and then I end up with the number of moles of hydrogen chloride, and then I'm going to convert that to sodium chloride. Now, going from one substance to another, definitely going to use a ratio, and they're in the ratio 2:2. So 1:1. Now guys, even if it's 1:1, you have to show that because it could have been 1:75. This is going to show them that you are going from hydrogen chloride to sodium chloride. So then it's just working out that mass, and then you put it into your percentage purity equation and you end up with 73.37%. Now moving on to a new question. Zinc oxide. Now they tell you zinc oxide is insoluble in water and can be harmful to the environment, and nitric acid can be used to neutralize that zinc oxide. And then they ask you calculate the mass of zinc oxide. So we're looking for the mass of zinc oxide that can be neutralized by, and now they give us a volume and also a concentration of nitric acid. So here they give us the incomplete reaction. We only need to look at the zinc oxide and the nitric acid. So I'm going to start with what they give us, which is the volume and the concentration of the acid, work out the number of moles of that acid. Then I'm going to use the ratio of 2:1 to get the number of moles of zinc oxide, and then I'm going to convert that to mass. So the first step, taking the concentration and volume to get the moles. Second step, going from HNO3 to zinc oxide. Now they react in the ratio, one of this will react with 2 of that. I've got the 0.0128 there, and it just means divide by 2 and I end up with 0.0064 moles of zinc oxide. And then we just have to convert to mass. Right everyone, that is all for today. We looked at mole calculations in the 2019 grade 11 final chemistry paper.